So here are your notes for today. You're going to take a moment to title your IP side, then write the essential question for today. How do chemical formulas prove the law of conservation of mass? Of course, you're going to copy the Avid notes from the slides that I'm going to show you. Write 3 questions and at least a 3-sentence answer for the essential question, and then highlight important facts. So pause the video in order to set up your notes. Here is the first section of notes. It is the statement of what the law of conservation of mass says. The law of conservation of mass states that the mass of the reactants is equal to the mass of the products. So yesterday you watched this in the BrainPop video. Let's say we had a model airplane that we were building. The reactants would be all the parts, and the product would be, of course, what we got at the end. So let's say that each part of this model airplane weighs 1 gram. Well, 1 gram plus 1 gram plus 1 plus 1 plus 1 would equal a total of 5 grams. The mass of the reactants is equal to the mass of the products. You wouldn't go 1 plus 1 plus 1 plus 1 plus 1 and then get a product that weighed 100 grams. That doesn't make any sense. Whatever you have at the beginning, you have to have at the end, or at least the mass has to be the same. Pause this, write a question, and highlight important facts. Section 2. Let's review that the subscripts is the small number behind the symbol and tells you how many atoms are in the molecule. The coefficients tells you how many molecules are in the reaction, and it's the big number in front of the symbol. So let's say that we had a new equation. 2O2 plus 2C, 2 carbon atoms, makes, remember that arrow means makes, 2 carbon dioxide molecules. So the question would be, is this equation balanced? If we were to draw it, 2 oxygen atoms, and I just drew them as squares so that we could see the difference between the carbon atoms and the oxygen atoms. 2 carbon atoms, but that's a molecule of oxygen, but we have to draw it 2 times because of that coefficient there. And if we were to draw the 2 carbon atoms, it would look like this. And then CO2 means COO, but we have to draw it 2 times because of the coefficient. And then on the reactant side, the total number of oxygen atoms, if we count them up, is 1, 2, 3, 4. So we would write on the reactant side we have 4 oxygen atoms. And the total number of carbon atoms is 2. On the reactant side, on the product side, oxygen atoms 1, 2, 3, 4, we have 4. Carbon atoms 1, 2, still 2. Is this equation balanced? We would say absolutely yes, because the mass of the reactants is equal to the mass of the products. Pause, highlight, write a question. Section 3. When a chemical equation is balanced, it shows the law of conservation of mass because we see that matter cannot be created or destroyed. Again, all the atoms are still there. They've just gotten rearranged to form a new substance. Here's the key, that matter cannot be created or destroyed, meaning that things can't just appear or disappear out of nowhere. Pause, highlight, and write a question. So here was your essential question. How do the chemical formulas prove the law of conservation of mass? And you can use this sentence starter to get you going to answer the essential question. Once you're done with your IP side, here is your OP homework. So for your homework tonight, you're going to have to determine if each one of these chemical equations is balanced or unbalanced, and then justify why it's balanced or unbalanced. And I'm actually going to teach you a new way, rather than drawing the bubbles each time, I'm going to show you a new way to determine if a chemical reaction is balanced or unbalanced. And then you can decide which way you like best. So pause this video to read the top of the instructions, and then I'll take you through the first few problems. So here's what I do first to determine if an equation is balanced or unbalanced. First, I draw a line to separate the reactants from the products. And then I'm going to draw a circle around everything except for the coefficient. So here's a story I always like, or a box. Here's a story I always like to tell. all the molecules are having a house party, and but they are leaving out the coefficient because they are too big to come into the party. So here's what we're going to do. Inside my box, I have a total of 2 hydrogen atoms, so I'm going to write H equals 2. And then oxygen atoms, also, there are 2 of them. Now I go to the product side. Now in this case, I have 2 hydrogen atoms, but this coefficient on the outside means that I kind of have to use like a distributive property in math and multiply that coefficient times everything in the house. So instead of drawing all the bubbles, I can just multiply the coefficient times all the subscripts. So 2H2 would mean that I have H on this product side equals 4, because 2 times 2 hydrogen atoms means I would have a total of 4. And then I would also have to do the same for oxygen. 2 times, if there's no subscript here, I can imagine there's a 1. 2 times 1 oxygen atom means that I have a total of 2 oxygen atoms, because 2 times 1 is 2. Well, in this case, I can obviously tell that this equation is unbalanced because I have 2 hydrogen atoms here and 4 here. So this is an unbalanced, please write out the whole word, unbalanced equation, because there are 2 hydrogen atoms on the reactant side and 4 on the product side. This equation actually does not exist in real life. Let's do a second one. First move, I draw a line to separate the reactants from the products. How many H's do I have? I have only 1. Oh, I forgot step number 2, which was to draw a box around everything, leaving out the coefficient. On this side, 4 times 1N means that I have 4 nitrogen atoms. I have a coefficient and I multiply it times everything inside the box. 2 times nitrogen, there's only 1 there, so 2 times 1 nitrogen atoms means I have 2. 2 times 4 hydrogen atoms, 2 times 4 means that H equals 8. Again, this equation is unbalanced because I have the mass of the reactants does not equal the mass of the products. Let's do another one. Step 1, draw a line down the middle of your equation to separate the reactants from the products. Step 2, draw a box around everything, leaving out the coefficient. And now I can total up how many atoms I have on each side. I have 3 carbon atoms, 8 hydrogen atoms, and 1 oxygen atom. Over here, 4 times 2 and 4 times 1 oxygen means that I have hydrogen. 4 times 2 is 8. Oxygen, 4 times 1 oxygen is 4. Now I can actually stop right here. Automatically, right off the bat, if I've got 1 oxygen atom here and 4 oxygen atoms here, automatically it is unbalanced, and I don't even have to do any more for this equation, because the mass of my reactants does not equal the mass of my products. Last one I'm going to help you with. Fe, oh, I forgot step 2, which is to draw a box around all of my molecules except the coefficient. I have 1 iron atom here because there's no coefficient or subscript. This 2 gets multiplied times the hydrogen and the chlorine atom. So that means that I have 2 hydrogen atoms and 2 chlorine atoms. Again, because 2 times 1 H and 2 times 1 chlorine. Now again, this is 2 different atoms, hydrogen and chlorine. Then for iron over here, I have 1, because there's no subscript or coefficient. For chlorine, oops, I have 2, and hydrogen, there's no coefficient, there's only a subscript, there's 2. In this case, 1 iron, 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen, This is a balanced equation because the mass of the reactants is equal to the mass of the products. You are on your own for the rest.